Okay, so when we factor polynomials, there's a couple of steps we want to go through. The first thing that we always want to do is we want to check for a GCF. Now when I say GCF, what I mean is a greatest common factor, okay? So that's something that you can divide everything by and not get a remainder. Greatest common factor. There you go. So for example, if I have 5x to the 5th plus 25x cubed. The coefficients here I can both divide by 5, so I can take that 5 out. And they also, this one has 5x's and this one has 3x's, so I can take out up to 3x's. So what's left, well, 5, show you this, 5 divided by the 5 I took out leaves me with 1. I started with 5x's here, but I took out 3, so that would leave me with 2x's. Plus, and now the same process, 25 divided by 5 would leave me with 5. And then I took 3x's away, and that's out here. So that's how I take the GCF out. If you were to distribute this through, you would come back to what you started with. Okay, so we always want to check a GCF before we start. Then what I want to do is I want to look for a pattern. Okay, and there's really two main patterns here that we're looking for. One is a sum or difference of two cubes. And this is after we take out a GCF if it has one. All right, so if you think about cubes, cubes are things that multiply by themselves 3 times to give you that number. So for example, 2 to the 3rd is 8. 3 to the 3rd is 27. 3 times 3 times 3 is 27. 4 to the 3rd is 64, and so on and so forth. So these numbers are perfect cubes. Now, they can also be variables, okay? Things like x to the 3rd is a perfect cube because x times x times x is x to the 3rd. X to the 6th is a perfect cube because x squared times x squared times x squared gives you x to the 3rd, okay? Oops, sorry. All right, so we have to identify that first. So this is just a pattern that you kind of plug and chug and remember as you go through. So let's say I have x to the 3rd plus, let's do 8. We'll start out kind of easy. All right, so here's what you have to do. When you set this up to factor, you do a small parenthesis and a big parenthesis, okay? You're gonna set your signs up first. Your signs, whether, and this is a sum of two cubes because of the plus sign, but the signs are always gonna be same. Then you're gonna change it, and the last sign is always gonna be plus. Okay, same, change, plus. And here's what you have to do. You look at this first term and you say, what multiplies by itself 3 times to give me x cubed? Well, because x times x times x is x to the 3rd, that means an x goes here. Same process with 8. What times itself 3 times gives you 8, and that's 2, so a 2 goes here, okay? Now I'm going to use these two values to form my trinomial that sits here. Take the first and square it, okay? Multiply them together, and then take the last and square it, okay? So x cubed plus 8 factors as x plus 2, x squared minus 2x plus 4, okay? Let me show you another example. Let's say do 27x cubed. I'm going to do this as a difference because remember it can be the sum or difference of two cubes. Minus, let's do minus 1. Alright, so the first thing I look for is a GCF, and this one does not have a GCF because there's nothing I can divide both of these numbers by. So what I want to do is I want to set up my parentheses, okay? So I got little parenthesis, big parenthesis. So what number times itself would give me 27, or times itself 3 times, excuse me, gives me 27x cubed? And I hope you said 3x, because 3x times 3x times 3x gives me 27x cubed. What times itself 3 times gives you 1, and that's 1. All right, so let's set up our signs. Same, change, plus. The 3x goes in the first spot and the 1 in the last spot. Square the first and put it in the first spot. And when you square it, be careful because you got to square the 3 and the x. So it becomes 9x squared. Put them together, multiply them together, and get 3x. And then square the last for the last term. Okay? Sum and difference of two cubes. Now, I told you to look for a special pattern. One of those patterns was sum and difference of two cubes. Another pattern is going to be a difference of two squares. Okay? Now remember, with cubes, it could be sum or difference. With squares, it can only be difference. Okay, so we're only looking for a minus sign. So it looks like I've got these two perfect squares separated by a minus sign. This is probably the easiest of the patterns because when you factor it, you do the square root of the first one, the square root of the last one, and then you do the same thing but change the sign in the middle. Okay, so if I had, for example, x squared minus 16, I recognize that these are both perfect squares, and sometimes it helps you to have a list of perfect squares off to the side of your paper. Because those are both perfect squares, I can factor it as the square root of the first minus the square root of the last, and then the square root of the first plus the square root of the last. Now again, I'm going to have to look for those GCFs to take out first. And you have to remember things about perfect squares. Numbers, of course, 4, 9, 16, 25, but also variables x squared, x to the 4th, x to the 6th. All of those are perfect squares because you can take the square root of them. There's something times itself that gives you that value. So let's say I have 6x to the 4th minus let's do 54. So the first thing I notice is that I can divide both of these by 6. So if you take a 6 out, it leaves you with x to the 4th minus 9. Okay? Now what I can do, I recognize that both of these are perfect squares. So the square root of x to the 4th is x squared. The square root of 9 is 3. And then I do the same thing with a plus. Okay? So that's really 2 patterns, but 3 if you count sum and difference as their own. Okay? So that's sum and difference of 2 cubes plus the difference of 2 squares that you have to look. Biggest thing also, remember, always look for that GCF before you start.